Does anyone know? That's all I got. Thank you.
So surely you see why that's my favorite talk of all time. It's absolutely amazing, and the fact that JavaScript ships those kind of things is absolutely absurd to me. The fact that we actually do that live today makes no sense at all either. So here's some more XKCD comics, because XKCD basically expresses everything that I'd love to express, but better. Because Randall Monroe is an amazing man. So see, here's like times I last had to open xorg.conf in satisfaction of how my life is going. You know, just programming is just terrible. It's a terrible art. Of course, on the internet, no one knows you're a dog, so that's also why programming is pretty bad. This is basic bug reporting. When you find a bug in your code, you look for someone who has also shared the same bug. They have asked a question online, they have marked they've solved the problem, and not explained how. So now you're sent lost in this wonderland, and you're looking for how we solved this, and there's no really way out. The only way out is basically to quit programming and move to a remote island. So, on to some real examples. Dash was a pretty good code source viewer that was released a few days ago, open source, after they had a few troubles with the Apple Store, or the Apple App Store. And you can see that this is one if statement. This is all one condition. It is 6,000 characters, well past the 80-character recommended limit, which not many people do follow, but still, there is 6,000 characters worth of conditions here, which is absolutely deserving of, as Gary Bernard says, whack. So within a few hours of publishing this, someone ended up pushing a fix to the repository, basically making this code cleaner. So they made this whole entire 6,000 line, as you can see on the red, that goes off screen, of course, because it's 6,000 characters, into a reasonable condition, where they not just check if that object's in the array, which they have predefined, they can modify easily. And then if they have anything else, the special behavior, they can define that side of the actual condition if the actual if statement succeeds. So it's not the best scenario. You still have a lot of if statements, not a lot of conditions that you normally know how to satisfy, but it's a lot cleaner to write, it's a lot easier to interpret what we're actually reading, compared to this mess. So let's talk about bad programmers. As you can see in the top line, that's actually part of the topic of one of the channels I'm in. Bad programmers on each channel, and it says you, because everyone on the channel is a bad programmer. Basically, anyone who's reading the topic and has a question should basically immediately go to that link, because it probably concerns them. So my friend Dustin, of course, is very aggressive, and he has immediately claimed that anyone on the channel is a bad programmer. And it's actually a great page, which I probably should go to. Actually, I will visit it just for a brief second. It was originally an Infogamer, but Infogami.
2 T's and how it.
Yes, you're right. Signs that you're a bad programmer. Poor understanding languages programming model, deficient research skills, chronically poor knowledge of platform features, inability to comprehend pointers, difficulty seeing through recursion. Signs that you're a mediocre programmer. And as you get towards the bottom, you start to see some resolution. He actually provides to you. And like, see, he has like symptoms. So like dysfunctional sense of casuality. So like some of the symptoms in his alternate careers, playing with slot machines in Vegas. And like indifference to outcomes. Alternative careers is like debt collection and telemarketing. So like it's just a really great article about bad programmers all together. And like colleague, actually if you go up here a little bit, insufficient ability to think abstractly, and like difficulty comprehending between objects and classes, contract negotiator, method actor. Collier-Boyer syndrome, unwilling to throw away anything including garbage, unwilling to delete anything, and then alternative careers, antique dealer, bag lady. So it's just an amazing article about, you know, signs that you're a bad programmer. And then of course, another great XKCD comic, just an example of SQL injections, because everyone has bad code that is SQL injections where you can just take over someone's database. So XKCD captures exactly what I'm trying to get, the point I'm trying to get at. So one of the big problems in computer science. No one really organizes code properly. It's really hard to do so. I personally spent 3 weeks on a project without writing a single line of code trying to figure out how I want to organize it. And if you ask anyone, any manager will think I'm insane. It's like, I don't want to hire someone to sit around for 3 weeks does nothing. I wasn't doing nothing. I was thinking casually about how I wanted to organize projects that later on in the future I wouldn't have to refactor everything, I wouldn't waste time. But in doing so, I wasted time. So, usually people just jump into code. They just jump right into it. I'm just going to write the code I need to write, and that'll be that. start to write more and more, you start to pile on this mess, sort of build up this pile of clothes. Here's something on the bottom you probably need for an event tomorrow, and it's very dirty, and you need to get it dry cleaned. You basically start to do a refactor. You clean up all the clothes, you're fed up with having clothes that you don't know where they are, they're a mess, and they're not clean. And you do a refactor. And refactoring happens quite frequently. Like, I've contacted jobs and I've wanted to refactor the entire code base. And of course, every manager will think, no way in hell am I let's refactor our code base. We have things to do. We don't have to play games making code look nice and pretty. Because managers don't generally care that code looks pretty. They care that it works. As long as it works, they don't care. Understandable. They have business, they have things they have to do. Whenever you do a refactor, it's kind of like cleaning your room. You find all this cool stuff that you haven't seen in months. You're like, wow, I really missed this toy that I played with a few weeks ago. And then when you lay things out better, you're saying, now you clean your room, you have like all things that you like on your shelf. You're like, wow, this is really nice, this is really accessible. I can walk in at home now, and everything that I need is right where I need it. Everything's perfectly lined up. And then as you start to buy more stuff, you come home every day from school and drop everything on the floor. You end up in the same situation. Of course, things are still nice on the shelf, but you still have crap everywhere. And as you write code, you need to refactor. There's no way out of it. So, I know teams, for example, at Apple, that do a refactor once every year, or twice every year sometimes, because they are probably the most necessary team on the entire iPhone project, besides, of course, the hardware teams. If they were to mess up one thing, the entire iPhone user interaction mechanism would be broken. So you would unlock your phone, or you wouldn't even be able to unlock your phone if they had a bug in their software. So they take everything very seriously, and they do refactors twice every year or once every year. And when anyone's interviewing for a job, they say, are you comfortable doing big refactors every so often? And if you're not willing to say yes to that, then you don't belong on that team. So one of the big solutions to this is abstraction. You abstract so you don't have to end up rewriting large portions of code besides things that you absolutely need and that are wrong. So now you waste time finding abstraction instead of waste time organizing code. It's about the same thing. It's about the trade-off between compile time and runtime. Like, would you rather have save time compiling your program and have everyone run it very fast, or would you rather have time spent for you to compile code and then have it run very slowly everywhere else? It's a trade-off, and usually people can get pretty good results by adding everything to compile time. And some people do that with C++ metaprogramming and those kind of things, which are quite scary. I hope everyone here knows what abstraction is, but for the sake of completeness, I will explain. Abstraction is the notion that we can interact with things and we can use things without knowing how they work. So, for example, I don't know how this keyboard works, but I can use this keyboard. Anyone in this room can use this keyboard without knowing how this keyboard works. And you can get me a keyboard made in any country on this planet that works any single way. And as long as the keys are laid out all the same way, anyone can use that keyboard. And that is abstractions. We don't know how it works internally. We don't care how it works internally. They can do whatever they want on the internal. As long as it works the way I know how it works, it is abstract to me, and it works fine. So you lay out code bases in terms of abstraction. You abstract things that you need that are going to change, probably that things that are bad, and put them somewhere else. And you have just a very few links to them. So I don't actually need to know how this keyboard communicates with the computer. I don't need to know how much electricity it needs. I don't need to know any of that stuff. I only need to know what actually each key corresponds to. So I'm getting the bare minimum of what I need out of this mechanism, and I'm pulling it out to what I need, and the rest of it is abstraction. I don't care. And that is the basic notion of abstraction in computer science, and is probably one of the most fundamental ideas that we ever work with every day, and just really something great to work with. So, abstraction. Virtual memory is the best thing ever. Seriously, virtual memory is the best thing ever. Like, without virtual memory, we sort of have a lot of issues, and we've overcome a lot of these issues historically with virtual memory. Computers wouldn't be where they were today without virtual memory. This idea that we can have something in one place, we don't care where we move to, it will still behave exactly the same. We can have a program running in the beginning of RAM, we can have it located anywhere in RAM, and it will still run exactly the same, it does not care. So like if a program needs 10 gigabytes of RAM, we only have 4 gigabytes of RAM, we can separate it out, and the program will still work exactly the same, even though half of it's on disk. Virtual memory allows us to do all of these cool things with little or lots of resources. So we have a big issue with memory fragmentation where like some processes will need 4 kilobytes, some processes will need 99 gigabytes of RAM. So if you have a process that needs 99 gigs and you only have 100 gigs, and you have something in the middle that's 4 kilobytes, then you have 50 gigs and then 4 kilobytes and 50 gigs, you have separation. This is really dumb. Why can't I just move that? Well, we don't even need to move it now, so we have things separated into pages. And virtual memory allows us to page things out, so we have separate chunks of memory that are all divided up individually, and the program doesn't actually know the difference. It doesn't matter. Any program on any architecture can still behave the same no matter how much RAM it has. Yes, abstraction, please. Please abstract everything. It is, while in some cases it can be bad, it can be scary, but abstraction is generally your friend. As I've said before, abstraction is the friend of the weak mind. Like our minds are not as great as we like to think they are. I mean, they're very great. They're incredibly big. They have so much like storage and RAM capacity, so many things. But when we're trying to solve a problem, and there's 15 factors we need to include, then it's very hard for us to try to include all those factors at once while trying to it's trying to basically get everyone what they want in like a room of 100 people. You can't possibly decide on what everyone wants in a room of 100 people. They don't contain things all at once. We simply can't handle it. So we abstract things away. We let someone else worry about it, probably us later on. But we say, hey, this works as we intended to work, and that's the end of it. And if it doesn't do that, then we'll fix that later. But for all intents and purposes, this works exactly how we expect it to, and that's it. Keeps everything very simple, that allows us to think much more clearly, and we get a lot of really cool things done that are really hard. So, like I said, using abstraction to bridge the implementation. So suppose you're trying to make a car, and you want to make a new engine. You know how generally cars have exhausts in the same place? Like, so if you were to take a frame of a car and drop any engine into it, they all have the same, they don't necessarily all have the same hookups, but if you were to think of a car as a general, like a pretty clean idea, it's not, cars are actually pretty messy. But for the most part, every engine has the same components that all hook up very similarly. So suppose you're building a car, you don't have an engine. Engines are very complex, you'll build it later. You build all the ports the engine's going to need, and those will be the bridge. That's how the engine communicates with the rest of the body of the car. That's as simple as you can make it, and as long as those individual ports are there for the engine to communicate with, your car should function just fine as soon as you drop any engine in there. Of course, this assumes that engines are very simple. They're not, but assume for the case that engines are pretty standard. Hard problems. How do we solve them? This is a great quote that someone gave me a few years ago. I have a math teacher who says fish are probably much better at us than calculating the product of two-axis rotations in three-dimensional space. It's true. Fish jump around a lot in three-dimensional space. They move around. So if a fish were to hit another fish, it actually would pretty much know very well where it's going to go if it was rotating in two-dimensional space, three-dimensional space. Whereas intuitively to us, we don't actually know how those things are going to affect physically because we don't do them. They're not native to us. And also this quote ties in a lot with, I had heard it originally with someone talking about if our math was natural or not. And basically the designation that our math was natural is that if we were to meet some sort of alien species in 10, 20, 100 years, would our math make sense to them? Would it be something they had also stumbled upon? If so, then maybe it's probably a natural thing to look upon. But until then, we have no idea if our math is natural or totally invented or made up. So,